Hello, Advanced Algebra students. I hope you're doing awesome. We are doing our last notes for Chapter 5. We're just doing the first 4 sections this year. So far, we've learned how to rewrite radicals using rational exponents, how to determine reduced radical forms of expressions using properties of exponents, and how to graph radical functions. Now we're going to talk about how to solve radical equations. So there's a variety of problems that kind of fall within this category, and I thought what we would do is a few of each. Neither of them really take that long, and then that way you could get some extra help getting ready for the homework and the test. So let's kind of go over the basic steps that we would need to use. Let's say, for example, our problem is the square root of x plus 5 and then minus 1 equals 3. We do want to isolate the radical. So to do that, we would have to add 1 to both sides. After we isolate the radical, then we want to raise both sides to a power so that the radical is eliminated. So for example, in this case, it would be the power of 2, because that would cancel out the radical symbol and my left would just become x plus 5 and the right would be 16. After that, we want to solve for x by subtracting 5. And then we do want to check for extraneous solutions. So we plug it back in and see if it works. If we plug 11 in, we're taking the square root of 16, which is 4, minus 1, which gives me 3. And I can see that that solution works, so I can keep it. Let's look at example number 2. Here we've got the cube root of x plus 2 equals 4. And again, we want our first step to be to isolate the radical. So I'm going to subtract 2 from each side, and I'm going to get the cube root of x is 2. And then I want to raise both sides to the third power in this case so that I can cancel out the third root. And I'm going to get that x equals 8. If I plug 8 back in and take the cube root of 8, I can take the cube root of 8, which is 2, plus 2 more and get 4. And again, I can see that that one works. All right, let's take a look at example 3. I've got the square root of 3x minus 2 equals x minus 4. In this example, step 1 has already been done for us. The radical is already isolated. So I want to raise both sides to the power of 2 to cancel out the radical on the left. My left now is just 3x minus 2. Be careful on the right. X minus 4 quantity squared is x squared minus 8x plus 16. Now I do have an equation here with an x squared and an x in it, so I need to get everything on one side. I'm going to subtract 3x and add 2. So I'm going to have x squared minus 11x plus 18 equals 0. I'm looking for two numbers that multiply to make positive 18, but add to make negative 11. So I'm going to use x minus 2 and x minus 9. When I set these equal to 0 to solve, I get two solutions, positive 2 and positive 9. Now let's plug them back in and see if they work. If I plug 2 in, I'm taking 3 times 2, which is 6, minus 2, which is 4, and taking the square root of 4 to get 2. Is 2 equal to 2 minus 4 or negative 2? No. So we can see that the actual answer is not correct for 2. We have a solution, but it's called an extraneous solution because it doesn't work when I plug it back in. However, let's try using 9. If I put 9 in here, 3 times 9 is 27, minus 2 is 25. The square root of 25 is 5. And on the right here, if I take 9 minus 4, I also get 5. So that one does work, and I can keep the solution of x equals 9. All right, another common type of problem that we come across when we are trying to solve radical equations is to rewrite a formula. So let's do a few examples of that. Example 4. Let's take a look at x equals the square root of 3y over 30. For me personally, I like to solve this by cross multiplying. I'm kind of a visual learner, so it's easier for me to see. I take 30 times x on that diagonal and radical 3y on the other. If I want to solve for y, I'm going to need to square both sides so that I can get this to just say y here. 30x squared is 900x squared. And then the square root of 3 times y squared becomes 3y. To finish solving for y, I would need to divide by 3. So I'm going to get y equals 300x squared. In this particular case, we're basically just reformatting the problem to solve for a different variable. Now, for example number 5, I have x equals 1/2 times the 4th root of y. In this particular example, if I want to isolate y, I would multiply by 2 first on both sides. The reason is that I want to isolate the radical that I have. So I'm timesing by 2 here, timesing by 2 there. The nice thing about doing that is that this 1/2 goes away. So now I have 2x equals the 4th root of y. Again, I do need to raise this to the 4th power. 2 to the 4th is 16, so this is going to be 16x to the 4th equals y, and that problem will be done. As I mentioned, there's several different types of problems in this assignment, and just because you are taking the time to watch the notes today, I'd like to really help you out by giving you a few of each type so that you can really understand this. Now, we have a radical on one side. If we want to isolate it, I would divide both sides by 2 so that that 2 cancels out. Now on the left, I've got x over 2 equals the cube root of 12 plus y. Again, we need to raise both sides to the 3rd power, so I have x cubed over 8 equals 12 plus y. Now, if I want to isolate the y, I would need to subtract 12. So I would have x cubed over 8 minus 12. Now, sometimes we will have an equation with rational exponents. So instead of being, say, something squared or something cubed, we'll have an equation with exponents that are fractions that we're trying to solve. So let's do a few examples of that. Example number 7 could be x squared plus 5x plus 5 all to the 5/2 power is equal to 1. Now we want to use the same basic strategy that we did in solving an equation with a radical. And that is that we want to raise both sides to a power that will make this rational exponent become an integer exponent. We're going to do that by raising it to a power that is a reciprocal of what we originally had. The reason is because then when I take that power of a power, my exponent will become 1. So this is just x squared plus 5x plus 5 to the power of 1, or just x squared plus 5x plus 5. This is 1 squared, which is 1 times 1 or 1, and then the 5th root of 1, which is again just 1. I would need to now subtract 1 from both sides. Again, anytime you have an equation with an x squared, you do want to see if factoring will work. So when we factor here, I need 2 numbers that multiply to make 4 and add to make 5. So it's going to be 1 and 4. And when I set these each equal to 0 and solve, I'm going to get -1 and -4. And both of these do work when I plug them in. All right, let's take a look at example 8. So I've got x squared minus 3x minus 6 all to the 3/2 power minus 14 equals -6. We're going to follow, again, the same steps that we did before. We do want to isolate our radical or our rational exponent. So we want to add 14 to both sides here. And then I need to raise both sides to a power that will make the exponent become 1 here. So we're going to use the reciprocal and use 2/3. The left-hand side will now just become x squared minus 3x minus 6. On the right, I like to think of this as the cubed root of 8 squared. If we do the root first, it means that we have smaller numbers to work with. The cubed root of 8 is 2, and 2 squared is 4. So this is x squared minus 3x minus 6 equals 4. I need to subtract 4 from both sides to get x squared minus 3x minus 10. And again, anytime we have an equation with an x squared, we do want to try factoring. The two numbers that multiply to make negative 10 and add to make negative 3 are negative 5 and positive 2. If I solve for both of these, I get 5 and negative 2. And I do believe that both of those work when we plug them in. All right, I just want to do one other quick example for you. Example number 9. And this is what to do if you have an equation with 2 radicals in it. So I will show you how to handle that. Let's say for example 9, and this will be our last one, that we've got the square root of x plus 9 minus the square root of 2x is equal to 3. So this can be somewhat involved, but what we want to do is get one radical on each side. So I am going to add the 2x to the left, the square root of 2x, and add it to the right. Now I have the square root of x plus 9 equals the square root of 2x and then plus 3. I do want to square both sides. However, be careful because on the right it's fairly complicated. We are in essence foiling this work here. So I'm taking the square root of 2x plus 3 and I'm multiplying it times the square root of 2x plus 3. For my first terms, the square root of 2x times the square root of 2x is just 2x. And then I have plus 3 times the square root of x and 3 more times the square root of 2x and then 9. So when I combine these, I get 2x plus 6 times the square root of 2x plus 9. So now I've got 2x plus 6 times the square root of 2x plus 9. Now we need to keep going and use the same process a second time. So I want to isolate this radical here. I'm going to do that by subtracting 2x and subtracting 9 on the right, subtracting 2x and subtracting 9 on the left. These will now cancel out. On the left, negative 2x plus 1x is just negative x. 9 minus 9 is 0. And I've got 6 times the square root of 2x on the right. We're getting really close, but we can see we still have not isolated this radical, so I want to divide both sides by 6, and then I want to square both sides. So when I square negative x, it becomes positive x squared. 6 times 6 is 36, and on the right I have 2x. This is definitely one of the more difficult problems we've done. From here, I would go ahead and cross multiply. And I think I'm going to erase this extra work I did off to the side just to give ourselves a little bit more room. So I would cross multiply. On this diagonal here, I'm taking x squared times 1. And on this diagonal here, I'm taking 2x times 36. So I'm getting x squared equals 72x. I'm going to subtract 72x and then take the GCF, so x times x minus 72, and then set each equal to 0. So I've got two solutions, 0 and 72. Let's check both to see if they work in our original equation. So if we plug 0 in, the square root of 0 plus 9 is the square root of 9, minus the square root of 0 Is that equal to 3? Yes. So when we plug 0 into our original equation, we do get something that works. So we can go ahead and keep this as a solution. Let's check when we plug 72 in. If I plug 72 into my original equation, I'm taking the square root of 72 plus 9 minus the square root of 72 times 2 and seeing if that is equal to 3. The square root of 72 plus 9 is the square root of 81. This would be the square root of 144. So is 9 minus 12 equal to 3? Or is negative 3 equal to positive 3? And the answer is no, that does not work. So that means that this solution here we have to cross out. It is an extraneous solution. All right, I'm so proud of you guys for watching your notes. That was the last notes for chapter 5. See you soon. Bye.